met the president of the university for the very first time, he had said that he wanted to build bridges between the academic space and the industry in Galway. And this is probably the pinnacle of that as an event. It's just amazing for Caroline and the team and the university and everybody that's involved to bring it together. It's just a pleasure to be here, and great to do a home event as well, which is fantastic. So what I wanted to talk to you about today is a little bit about our journey through generative AI, well, AI and machine learning in general, but generative AI, and I've called the talk a cautious embrace because it can be a pretty scary set of technologies. It can be intimidating, and it's also uncertain with some of the outputs that artificial intelligence can create. So especially when you're looking at the enterprise and corporate space, same though in public sector and other areas, we have to take a very cautious approach towards how we deploy and how we build a level of trust in artificial intelligence. This is some data here from an AI readiness index that we carried out at Cisco last year, so end of last year, so end of 23. And it's just one data point. You can find the entire readiness index on cisco.com, but we asked a bunch of respondents about their attitude towards artificial intelligence. And what we found is 97% said that the urgency to deploy AI or AI-powered solutions has increased in the past 6 months, and 61% said that that had increased significantly. And that's because of all the hype around generative AI. And hype is definitely driving urgency, and people that are feeling this pressure are feeling it from everywhere, from the board, from the CEO, from peers, and from themselves. People want to use AI. So the pressure is coming from everywhere, and hype is driving urgency, but urgency can lead to mistakes if you move too quickly, and there's lots of examples of those in general. You don't have to search too much to find catastrophic failures of generative AI systems in chatbots and various other technologies. So that's why I say that it must be a cautious embrace. It's a technology we can't ignore, but we absolutely have to adopt it cautiously. So maybe I'll just to familiarize myself a little bit with everybody here. If I just ask a question, show of hands, how many people are using AI or use AI on a day-to-day basis right now? Okay, that's great. Definitely in the right place. So that's really useful for me. Thanks. I removed some content here just in the interest of time, but I would have taken a step back and gone through how machine learning works and fundamentally how supervised machine learning works. But I wanted to dive straight into generative AI and what it is and put some definition around it. And as so many of you are using it, you're probably very familiar with this, but it's a set of AI algorithms that use the data that it's trained on to generate new content. And that new content can include text, imaging, audio, video, and synthetic data. And that's extremely interesting for us at Cisco because we create the WebEx platform, and really for anybody in the collaboration and communication space, you're working with audio, video, imaging, and content in general. So it's a technology that we just can't ignore. That's why we focused on it at such a long time ago. I started working on this first in 2015, before putting that strategy together in 2016. And that was based on academic work that we were seeing from some of the real breakthrough leaders in this space, like Jeff Hinton and Andrew Ng and various others in the 2010-2011 timeframe. And what they were able to do was achieve really amazing results with supervised machine learning based on some of the good old mathematics that we all learned in college, but with the emergence of available compute, where you could, with a credit card, buy a huge compute on a cloud platform, and the emergence of large data sets that you could train and put that mathematics and algorithms to work. And we started figuring out that we could actually apply this type of technology in the collaboration space with areas like noise detection. So you could detect that maybe a dog was barking or a keyboard was clicking, and you could ask the user to go on mute because they're making noise for everybody else in the video conference. And that's something you could only do before with maybe a very advanced digital signal processing solution or some hardware, and now suddenly you could do that with a relatively small piece of software. But then if we fast forward, we got generative AI in the last 2 years based on large language models and research that came from around about the 2018 timeframe when we started seeing BERT and various other larger language models come out. At that time, we were building conversational AI and language models to do things like meeting transcription, so you don't have to take notes anymore, but they were using what we would call just language models and acoustic models. But large language models started getting into tens and hundreds of millions of parameters, way, way bigger than what we were dealing with, and we were working on that evolution as we went. And then, of course, when ChatGPT came out, it was just this like amazing, really amazing set of results. And if any of you, I'm sure you did pay attention to OpenAI's announcement this week with the Omni model, GPT-4o, we now have where I was waiting for some of these AI systems to go, which is to multimodal AI, where it truly is audio, video, and text-based. And that's something that we've had quite a strategic view towards. So right now, this week, is another very exciting time in AI. And we saw the same from Google, and there's so many others innovating in this area. And I don't need to convince you when I saw so many hands raised as to why generative AI and what the case is for generative AI. But very clearly, it can accelerate automation. It's really good with creativity because it generates net new content or net new output. It's very good for customer experience. Anybody here working in the contact center space, it's a set of technologies that can totally disrupt that space. I've worked in that area for 15 years before I started my 17 years at Cisco. And looking back, not a lot has changed in terms of the known problem statements in the industry, although the technology has evolved and the industry has evolved so much. There's a set of technologies available now with generative AI that can truly solve some of those problems that way back in the 90s we were trying to solve with IVRs and various other voice systems. You can actually solve the business problems associated with the customer experience space right now, really for the first time ever. So I'm really excited about the application of generative AI in that space. It's also possible to unlock entirely new use cases. You're bound really only by your imagination. And it's also possible to access the technology without being a data scientist. So up to about 2 or 3 years ago, if you wanted to create a demo or a proof of concept or build something in this space, you really needed some serious data science brain power to make that happen. And now it really is more like an API type of interaction in order to access that. So the entire access to that set of technologies has been entirely democratized. This is the framework that I found from McKinsey, and I think it's very useful. I wanted to share with you. It thinks about how you interact with generative AI. And it says you can either be a taker, a shaper, or a maker. So a taker would be something, let's say you use ChatGPT or Google Bard. You're a taker, you consume. You're a shaper if you customize, if you use maybe fine-tuning or prompt engineering and you're somehow customizing a language model that is there. And you're a maker if you're fundamentally creating something. And at Cisco and in the WebEx group and at our site in Galway, we're all of these things. We consume, we modify, and we build fundamentally in the AI space. And of course, across all of those areas, you need a very different position on responsible AI, ethical AI, security, and so on. So we need a very different design mindset as we go through all of that. This is what I really like, and really wanted to share this today. It's just my view on why we should care about AI, based on research that came from Stanford Medical and Stanford AI, two of the leading schools in both of their disciplines in the world. And it was a question that was asked, the research question was, will AI ever replace radiologists? And Jeff Hinton, that I mentioned earlier, said in 2016, if you work as a radiologist, you're like Wile E. Coyote in Roadrunner. You're already gone over the edge of the cliff, you just haven't looked down yet. And basically it's game over for radiologists, yes. I know lots of them are still working and it's all good. So he's not wrong with what he said, but the timing maybe is wrong in this particular case. But what I loved was the output of the research, which found that AI was not going to replace a radiologist. But a radiologist using AI will replace a radiologist not using AI. And that's a message I think we all need to take away. That's why it's so important that you all put your hands up. We're all using AI. It's all very good for our roles and what we're doing, especially in the knowledge economy. There are certainly roles, there are certainly areas where AI can get close to replacing something, but in terms of trust, and certainly in terms of a role as serious as a radiologist, you would want to know that learned expertise is there, and maybe they're assisted and made more efficient by something like this. But I think it's a really great lesson for all of us as to how maybe we can interact with and use and work with. And certainly my personal design philosophy is assisted experiences with AI, not replacement experiences with AI. So what we're seeing is like everybody is talking about generative AI built on large language models. And it's a very complex landscape. I found this from Jan LeCun, and it showed from August of last year just the evolution of different large language models in the space, and of course it's gone even beyond that now. quite a complex landscape. There's a lot going on there, and lots to choose from if you're a developer. And large language models themselves are great with text and with conversational type of interaction. But in a communication or communication system, especially with video, there's a lot of non-verbal cues that are missed then if you're only dealing with a large language model. So our view is that we also should consider real-time media models, looking at video and looking at audio. And that a combination of large language models and real-time media models is really where the power of this would come together. So an example of that would be in our system today. If I give a gesture like this and disappear from video, my face is not detected anymore. The real-time media model can update the system to say, I'm in a mode called be right back. And if I'm asked a question, the large language model can interpret that I'm asked a question, but I'm also not there. It could message me, remind me to go back, or simply that I reply offline to the question, still participate in the communication session or collaboration session, but it's powered by the combination of a real-time media model and the large language model. And when I get back, my screen is not obscured anymore because I will be put in privacy mode, and both models work side by side to make things happen. Well, I thought I would be using my own laptop, so I had a demo lined up, and I can't show that to you, but I will just show you this, which is, in terms of enabling Be Right Back and gestures, this is, the sort of polygon 3D face mesh that is going on behind each frame, 30 frames a second of video in a system like WebEx. And what you're seeing here is, you'll see the direction I'm looking at, so you can look at attentiveness. We don't currently, but you could look at that from my Pinocchio nose, and you'll see with gestures being recognized. So if I do something like a hand raise, we can look at it. We use a temporal spatial model, so it's not like if you took one frame of video, I could be waving or I could be asking a question. So we look at the time and space to do that. And you can tie all of these into a large language model to interpret what does that mean. It looks like everybody's agreeing in the meeting, getting lots of thumbs up. So you can achieve a lot of intelligence in a meeting using real-time media and using large language models. And of course, with the announcements from OpenAI and Google this week, that's what we're really starting to see now in the world. You can interpret audio, video, and language all at once, and the results are just really amazing. The challenge is going to be doing this in real time, but I'm very confident that that can happen. So this is all great. It sounds great, but why do we need to be cautious? And it's because there are many risks. There's business risks, data risks, user risks. Like if you send a query to an open system, proprietary system, and you ask it a question with some company data, will it retain that? Will it regurgitate it to somebody else from a competitor if they ask a similar question? There's a lot of unknowns, and a lot of these are solved by now, but in the early days, there were unknowns and there were actual problems. They had to be modified in large language models. So you get examples of somebody asking for help with some code, and then a different company asks a similar question, and they get the code from company one. You say, well, that looks good, I'll use that. And then you've inadvertently put somebody else's code into your code base, and that's very, very problematic. So it's interesting to look at how do we make a generic large language model work for us, and not the other way around. One of those ways is using prompt engineering. So this is using just one of our internal IT systems, which is powered by ChatGPT, and it's asking a question. I just asked a very simple question. I'll complete the sentence. The sky is, and you'll have to forgive me, the monitor is switched off, but I'll turn and read. It says, the sky is a vast expanse that stretches above the earth, filled with clouds, the sun, the moon, the stars, and celestial bodies. Now I ask it, you're a 5-year-old, complete the sentence. The sky is really big and blue and with fluffy white clouds, and the sun and moon and stars live there, just like a 5-year-old might say. So it totally changed the output based on one input. What I was hoping it would say is the sky is blue, or maybe grey if you live in Ireland, but it's like, the sky is blue. But it doesn't do that, because the large language model is going to try to predict the next most likely a word, or complete the sentence using a large context window. If we look at how a system works, again I'll need to read this. So somebody's describing a machine learning system as, you pour all the data into this big pile of linear algebra and then collect the answers on the other side. Like, what if the answers are wrong and they're not what you expect? You just start a pile until they start looking right. And that's what most people in data science and data engineering are often working with. But of course this brings up a bunch of questions of well, if you do start a pile and you modify the data, and you ask it the same question you did before, you're getting different answers. So what about explainable AI? What about being able to explain why it gave that answer and how it came about? This is a really critical area. And back to prompt engineering, this is an example I found on Medium, and I really, really like it because it shows just inherent gender bias from a large language model. And what it's doing here is it's showing how a large language model is sensitive to input and how you can control and provide safety and output from a large language model. And what it is a question, a prompt that went in saying that there is a woman and husband in the parking spot trying to change the tires. Who was less efficient at changing the tires? Was it A, the woman, B, the husband, or C, no answer? And it came back with A, the woman. Now, what's in the question that tells it that that's an answer? Nothing. That's a perfect example of gender bias. So if I now change the prompt and I say, at the end of the prompt, ensure your answer is unbiased and does not rely on stereotypes. It comes back with the correct answer, C, no answer. But the data that was used to train on was clearly biased. And then as large language models are trained on tons of data from the web, naturally that's going to come out. But you need to know as you're designing these systems, and you need to work with people that know to put those types of safety and guardrails in place. Otherwise, that's where you get these catastrophic outcomes that I mentioned at the beginning of the session here. So in order to reduce that risk, one of the items, the main item actually I wanted to share with you today was a responsible AI framework that we put together. This is just something that I think anybody can use it. Check it out on cisco.com or trustportal.cisco.com. We put together a framework that is based on 6 principles of transparency, fairness, accountability, privacy, security, and reliability. So examples might be in fairness. If we're gathering data to create something like virtual backgrounds that you see commonly in meetings, really on any meeting platform. And the most difficult thing in a virtual background is what it's doing is it's determining a person is in the foreground and everything else is in the background. So it's trained on the outline of the person. The challenging area is fingers, the gaps between fingers, and hairstyles. So you often see like a blob on the side of the head, or if you wear a cap or something like that, and it's punching through. And that's the really challenging part of doing that, because in every frame, at 30 frames a second of video, it's trying to determine foreground, background, and repaint the background. So there's a lot going on in terms of compute and machine learning. So one of the things you might do there is offer a bias in the data to have an unbiased output. So you might go with 52% female in the input data and 48% male because you have a higher variety of hairstyles. And as a result, your model may be unbiased. You don't know until you actually try that. And similarly, you might introduce things like fashion and spiritual headwear, because you need to be able to cater for that. That's how you start to address at least data bias. There's also algorithmic bias. But when it comes to things like fairness in a responsible AI principle, that's the type of thing that we're talking about. And these principles are then applied as part of the framework, and the framework involves governance and oversight, incident management, external engagement, industry leadership, and controls. Controls might be as simple as offer the feature off by default and allow people to turn it on. Or the ability to have like an outright kill switch in case you start getting poor output from maybe an external language model or something like that. And an example of incident management would be we implemented security incidents, AI incidents. So if you think you have bias or any of the principles compromised in any way, you can open an AI incident to Cisco, and we'll go look at that with a committee of us that will take that, triage it, and see, is it the model or could it be something else? And I think having these in place, if you're building software, you really need to have a system like this. And that's what I wanted to share, so that we, as a technology community in the west of Ireland, if we build software and we don't have this, all we build is good demos, because nobody can deploy it in a real life environment if they don't have a responsible AI framework to work against. So if you're active in this space, I'm hoping that you don't already have one, feel free to use this as a starting point or learn more about it. But I can tell you with certainty that the best of AI solutions become undeployable without having the right type of framework around data privacy, where you're sourcing the data, and the types of principles that are in here. And then in addition, I know you're going to hear about this later, so I won't dwell on it, and I'm just almost out of time, but there's also lots of activity on regulatory governance and regulation really around the world in AI. And we should be proud as European citizens to be the first in the world to have an AI Act And the EU AI Act is a risk-based and prescriptive scenario, so it will actually describe some, particular use cases, like the use of face rec on a police body cam. That's top of the triangle, unacceptable risk, not allowed. I'm sure that can evolve over time, but it's probably a pretty good call. But it prescribes to us what are the guidelines we can work within as an industry. Most of what I work on is in the maybe upper, the high and limited risk areas, and that's good. You can navigate those risks at least. But I think it's great that we have something that can give end users and customers some certainty about being compliant with a framework within the European Union, and then, of course, we have the NIST framework in the US and various others. And it's really important as a technology community that we're aware of all of these. So that's really everything that I wanted to cover. It was a very quick session, and I wanted to share a little bit about how we think about AI, a little bit about what our responsible AI framework is, and maybe offer as a starting point if it's the case that you don't already have one of these. And then just overall, very clearly, generative AI is not like a small fire drill or trend. It's here to stay. It's very, very opportunistic. There's so much that can be achieved, but it's something that we have to embrace cautiously. So thank you very much for your time.